Section 1.10 in Chapter 1 is called the per unit system with one base. If we select the size of only one quantity as the thing that we want to compare, then we're saying that the per unit system that we're talking about has only one base. And this base might be a voltage, it might be a power, it might be a current, a velocity, whatever we choose. But for this particular comparison, we're only looking at one characteristic. So for instance, he says maybe there's 3 motors, and these 3 motors all have different horsepower ratings. And so let's see, what does he say as we're looking at this? He says that the 3 motors that we're comparing have values of 25 horsepower, 40 horsepower, and 150 horsepower. Okay, so we'll write those up there. We've got we've got 25 horsepower, we've got 40 horsepower, and we've got 150 horsepower. So here are 3 different motors, all have different ratings, all right, in terms of the power that they can deliver. So let's choose an arbitrary base here. Let's say that our base for comparison is 50 horsepower. We don't know where that came from. We're just going through a process here. And then so we're going to compare each motor to the base. So for the first one, it's to make that comparison, I'm going to say 25 horsepower to 50 horsepower. For the second one, 40 to the base of 50. And for the third one, 150 to 50. Again, always remember that the base value that we're using is going to be in the denominator. Always in the denominator. Then we'll come up with a unitless value that will describe a specific motor, in this case, to that base value. So as we look at these individually, we'd see that the first one is 0.5. We would see that the second one is 0.8. And we would see that the last one given is 3. These are per units. They are unitless. They make a easy comparison of a specific motor to the base value. Another example that he gives us, let's see if I've got some room. I do. I'm going to slide that up here. Another example, he says we could have selected a base power of 15 horsepower. If we had done that, again, comparing these motors, the first one of the 25 horsepower, that comparison would be 1.67 per unit. And he gives us a few more examples, you know, throughout that. He mentions that it's important to know the magnitude of the base of the per unit system. If you don't know this value, the actual values of the quantities that we're dealing with can't be calculated. And so this whole concept, this whole per unit idea, it can be applied to a lot of things. The first thing that he shows us here is in figure 1.3, okay? And in 1.3, what we got a series parallel circuit. And on this circuit, we have a 3,500 ohm resistor and a 4,800 ohm inductor, a 3,000 ohm capacitor, and here's another resistor given a value of 450 ohms. Of course, these are impedances that we're dealing with. And so what we're going to do here is, for this particular circuit, we're going to select a base impedance. We're going to select a base impedance of 1,500. And then we're going to compare each one of these values to 1500. So I'm going to compare this to 1500. I'm going to compare this to 1500. I'm going to compare this to 1500. And I'm going to compare this to 1500. Again, these are per unit values. They come out with no units associated with them. They're a number to compare to the base. Base is equal to 1500 ohms. All right, so if I go through and I do these calculations, I divide 3500 by 1500, and this by 1500, and this by 1500, and this by 1500, I would end up with the equivalent circuit shown in figure 1.4. The per unit circuit, which we would call this now because these values are not actual, they're per unit values that have been substituted, contain the same elements as the real circuit, but the impedances are now expressed as per units. We could go about solving this problem just as we would, any other circuit. These would be the numbers that we used in that. And to be able to do that, we would recognize, of course, that since this is an inductor, that would be a positive J number, and this is a negative J number. This is, just the real values with this. And I will say, too, don't worry so much about the particulars of the calculation and the J numbers and all that. We're going to do some review about that. I know that in particular my class, in my ELC 131 class last semester, we were getting to the end of the course. We were running out of time. Everything was just changing by the moment. And, the things that we did there, we could probably use some remediation in. And we're going to do that. But the point here is that I want you to see, here's an application of per units. Here's figure 1.4 with the per unit circuit J notation, where we look at this as a negative J and a positive J, and this is a real value. When we get into that, it's plus or minus the J value. But again, we'll do some remediation and look at some of that later through here. But again, I guess that's really it for this section. Just a explanation or sort of an enhancement of this per unit idea, and also seeing what we call per units for one base.